So here we'll be discussing row echelon form and reduced row echelon form. So these are two terms. Please take note, very important. The first one is row echelon, and the second one is reduced row echelon form. Now, let's start with the first one. It said a matrix is said to be in row echelon. For a matrix to be in row echelon, it must satisfy how many criteria? It must satisfy three properties, these three. What is the first one? The first one says that the first non-zero number in each row, when you move from where? Left to right, must be what? Must be 1. So if you have a matrix, if you look from each row, as you move from the left to right, the first non-zero element must be what? Must be 1. This element is what we call the leading entry. Right? So if you take, for example, this matrix here, and try to, this matrix, this one. Now, if you look at this row 1, look at row 1. If you look at row 1, the first non-zero element is what? Is 1, yeah? Okay? So it means the first property is satisfied, right? But not property, you have to check all the rows. But if you look at second row, the property is also satisfied because 1 is the first what? Is the first element. So it's also correct. If you look at row 3, you see that what? 1 is also the first non-zero element. But if you look at what? If you look at 4, also the first non-zero element is still 1. So you see this first matrix has satisfied all the property. It has satisfied only property number what? Number 1. It satisfies property number 1 because as you move from left to right, in each row, the first non-zero element you meet is going to be 1. But let's look what of property 2. It says the leading entry in each row is to what? Is to the right of the leading entry in the row immediately above it. So, for example, now look at this one. What is the leading entry here? This is our leading entry is 1. So it means the leading entry in the second row, because the leading entry in each row is to the right of the leading entry in the row above it. Now, in this second row, where is the leading entry? It is this one. But it is supposed to be to the right of the one above it. But here you can see it's to the left of which one? It's to the left of this, which is not good. It's supposed to be to the right, so it means it cannot be here. This one is supposed to appear somewhere here. So you can see that it has failed property number 2. And also you can see, you see this row 3, where is the leading entry? The leading entry here is 1. So if the leading entry here is 1, row 4, the leading entry in row 4 cannot be in column 2. It has to be to the right. So it means it can only be in this column. Right? So you see now this matrix is not in what? In row echelon form. Now, not because it failed condition 1. Condition 1 is correct. But it is not row echelon because it failed condition number 2. What is condition number 2 again? It says the leading entry in each row is to the what? Is to the right of the leading entry in the row immediately above it. Because every row you see, now this is row 1. So let's start from row 1 again. This is row 1. Yes. Where is the leading entry? This is the leading entry, which is good. So this is row 2. The leading entry is this one. So what is the relationship between this leading entry and this one? The first leading entry and the second leading entry. You see this one is to the left. But we don't want it to be to the left. We want it to be to the what? To the right. So it means in this second row, you cannot have a leading entry here. You can only have it here. because it has to be to the right of the leading entry in the row above it. All right, so that is why it failed. But if you now look at, so since condition 2 is failed already, then we don't even need to check condition 3. It doesn't matter. But if you look at this one, row echelon, the one in the middle, you see, if you look at row 1, this is the leading entry. So the first condition is satisfied. We have to check. If you look at this row, you see this is the leading. If you look at all of the row, the leading entries are where? Are to the right. So you see this is 1 here. This one is 1 here, which is to the right of this. This is also 1, which is to the right of this. So this is good. So it means condition 1 and condition 2 are all satisfied. Because what is condition 1? All the first non-zero element. If you look at each row, the first element you meet, which is not 0, is what? Is 1. So it means condition 1 is satisfied. Now, not just that, this, as you go from the first row to second row, you see that the leading entry goes to the right. So it's coming somehow increasing diagonally, right? Then condition 2 is satisfied. But condition 3, what is condition 3? It says that if all the rows consisting of entirely zeros are at the what? At the bottom. So you see now, this is a row which is entirely 0. It appears at the bottom. So since it appears at the bottom, there is no problem. It is part of the condition 3. So it means for something to be an echelon form, if you have a row that is entirely 0, then that row, the only place where that row can appear is at the bottom. If the row appear somewhere else, which is not the last row, then it means that that matrix will not be a row echelon form. So this is a row echelon form. It's not a problem because the zeros appear at the what? At the bottom. So no condition is violated. So this matrix in the middle, this is satisfy our what? Row echelon form. Now, then we look at these properties. So if you look at here carefully. So if you satisfy 1 to 3, 1 to 3 gives you row echelon. Now, let's read it. It said a matrix in a reduced row echelon form, if it is what? Row echelon. So if you have a matrix to be row echelon, when I say row echelon, it means it satisfies the 3 conditions above, and also it satisfies number 4 condition. So if it satisfies number 4 condition, what is number 4 condition? It means every number above and below each leading entry is what? Is 0. So if this condition is also satisfied, in addition to the earlier 3 conditions, then the matrix is called reduced row echelon form. So it means if you have row echelon plus what? Condition 4. Then this will give us what? This gives us reduced row echelon. So this is now reduced row echelon. All right. So just as you can see in this table here, look at this matrix. This is just like already it's what? It's echelon. So this is just this matrix. This is just this matrix. The difference between this matrix and this is that what? As you can see, is that look here. These are the leading elements. If you look at this leading entry, if you look at this leading entry here, this is a leading entry. But you see the number above it is -6. It's not 0. If you look at this leading entry, The number above it, you have how many numbers? Two numbers. All these numbers are not what? They are not zero. So it means that this is not a reduced echelon. It is only echelon, because in echelon, once you have a leading coefficient or a leading entry, the number below it must all be zero. So here you can see this is 1, everything here is 0. This is also 1, everything here is 0. So the number below it has to be 0, but the number above it are not what? They're not 0. So this is row echelon. But for reduced row echelon, look at the leading here. This is the leading here. All the number below it are 0, but there is no number above it, so it's not a problem. This another leading. You see the number below and also the number what? And also the number above it. They're all 0. Look at this one. You see the number below it, 0. The number above it, also 0. And here you don't have any. It's okay. There is no one here, but it's not a problem because the entire rows entirely 0. All right, so let's discuss some few questions here. So we have some few matrices here. That is example 2. We want to check whether the matrix is row echelon or what? Reduced row echelon. Now, remember, if you have a matrix which is row echelon, then it's possible it can be what? Reduced row echelon. So you cannot have a reduced row echelon without having a what? An echelon form, right? But, so let me just, okay, let's just do this one. So the first thing is, let's see row echelon. Is it row echelon? For it to be row echelon, we need to check. Just look at each row. Here we have only 2 rows. So these 2 rows, the first non-zero entry is 1. So this is good. Here also in the second row, the first non-zero entry is 1. So it means the first condition is satisfied. It means that what? Each row has a leading entry. Now, if you look at this leading entry, the leading entry also is good because they are increasing like diagonally from left to right. So this is also good. Condition number 2 is satisfied. And you can see there is no row that is entirely 0. So if there is a row that is entirely 0, then it has to be in the last row. But since there is no row that is entirely 0, it's okay. It's still fine. So it means it is row echelon. It is row echelon. Now you have to check, is it reduced row echelon? Now, for it to be reduced row echelon, all you need to check is what? You check the leading. This is the leading. How many leading entry do we have? We have this one. The number below it is 0. And also this one. The number below it and even above it is 0. So here you can see there is no number below it, so it's okay. But the number above it is also what? 0. So this is also yes. So it is both reduced and what? It was reduced echelon and also what? Echelon. Now, B. If you look at B, you start with echelon. This is 1. This is the leading entry. And also this is the leading entry. So this is also good. Yep, this is good. So this is row echelon is good. So row echelon, yes. Now, is it reduced? Reduce row echelon. Now, why is it not reduced? The answer is no. The simple reason is that if you look at this leading entry, look at this leading entry, the number above it is not 0. So the number above it is not what? It's not 0. So that is why it's a what? It's a no. Okay. Then number C, if If you look at number C, let's start with the first row. Yeah, this is our leading entry is 1. In the second row, yes, this is 1. In the third row, there is no 1, but everything is 0, 0, so it's good. We don't have a problem. And you can see after the leading entry, all the number below it are 0. The number below it is 0. This is our leading entry. The number below it is 0. But here in the third row, we don't have a leading entry. So it's not a problem since all the rows there are 0. So this is a row echelon. All the conditions are satisfied. Now, is it reduced? Now, for reduce, we cannot say it is reduced. It is not reduced. Why is it not reduced? Because if you look at this one here, what is below it is 0, but what is above it is simply not what? The number above it is not 0. So it's similar because the number here is 2. Then it means this is a what? It's a no. Now D. Looking at D, we just go row by row. This is our leading for the first row. It's fine. And you can see all the number below it's 0. So it's good. Now, if you go here, you see here is also 1. And all the number below it's 0. Then if you go to this one here, if you go to the third row, where is the leading term? The leading entry is what? Is 1. Yeah. So it means that what? It means that it is row. It is row echelon. Why is it row echelon? You see how the leading entry are also arranged. They are increasing from as you move from left to right. The leading entries are also increasing to the right. Yes, they are moving to the right. So this is row echelon. Yes. Now, is it reduced? If you want to know if it is reduced, just check the numbers below the leading, and because it has to be echelon before you can even check whether it is reduced row echelon. Yeah. So here you can see this is 1. All the number below it, they are all zeros. So you see, this is 0. This is our leading here. This is also what? It is also 0, right? Now, so it means that this is what? This definitely is reduced row echelon. Hmm. All right, now for this one, number 5, here you have also the same. So let's go this way. 1. This is 1 here. Now, if you go to this second row, now if you go to second row, you see there is no leading term, right? There is no leading entry. And you see that all the zeros are where? All the rows are zeros. Now, this is not allowed. This violates what? The third condition. Because for the third condition, for something to be an echelon, if you have a row that is entirely 0, then that row must be the last row. But you see in this case, this does not appear. It's not in the last row. So this is a no because of this row, which is entirely 0. So it means that what? Row echelon, we say it's a no. Now, since it's not row echelon, then we cannot even talk about reduced row echelon. So this also is going to be a no. So this is how we distinguish between a row echelon and reduced row echelon. So just note, let me just put it here. Every reduced row echelon is row echelon. Yes, because you cannot talk of reduced row echelon when it is not even row echelon. But every row echelon matrix, I'm not using the word matrix, but there should be matrix. Row echelon matrix is not reduced row echelon. All right. Now, so anytime you have a matrix which is not in echelon form, now can you convert it to an echelon form? Yes. What is the procedure? We will see is through the process of row elementary operations, and that we will discuss that in the next video. Thank you for watching.